Hello students, welcome to my YouTube channel PhysicswithS.Msir. If you are new to this channel, please subscribe the channel, and if you like the content of the video, please press the like button. And this gives me more motivation so that I can bring more number of videos for you. And today's topic is relative motion in 1D. So let's start the topic. What is relative motion? What is relative motion? Question is this. Now suppose, take an example. Suppose two cars are running. Okay. Two cars are running at different speeds. Say for example, it is running with a speed of 60 km per hour. It is running with a speed of 80 km per hour. And there is an observer standing on the ground. Now, when I am saying it is running with a speed of 60 km per hour, it is actually with respect to the earth. And when I am saying it is running with a speed of 80 km per hour, it is also with respect to the earth. And there is a man standing on the earth, so its speed with respect to the earth is 0. Now, think about this. If I look from the viewpoint of the man standing on the earth, correct? This car C1, this is car C2. So this person will observe this car is running towards right with a speed of 60 km per hour. This car is running towards right with a speed of 80 km per hour. But if you put yourself in this car, so what will happen? With respect to the car, you are actually at rest, correct? Because you don't know you are actually moving, correct? Which means if you know by looking at the surrounding. But if you sit on this car, with respect to the car, your speed is 0. So if I want to ask you, what is the speed of this car? What is the speed of car C2 with respect to this car? You will find it only the difference, that is 80 minus 60. Because with respect to you, it is not running with a speed of 80 km per hour. Its purpose is this, because this distance it is traveling in a certain time interval, you are also traveling certain distance in that time interval. So you will find what will happen, you will also cover certain distance in that time interval. So you will find speed is not too large with respect to this person. Or best example is this, think about another car C3, which is also running with the same speed, 80 km per hour. Okay. So what we'll find, this driver can talk to this driver can talk to this driver. This is only possible. This person cannot able to talk to this driver. Drivers cannot talk to this person. But these persons can talk to this driver, this person can talk to this driver, because with respect to each other, they are at rest, because they are at the same speed with respect to the ground. So they will think each other at rest. Correct? So this is the concept of relative speed or relative velocity. So technique is this. And think about another example. Suppose a car is running with a speed of 60 km per hour. Another car is running at a speed of 80 km per hour, but both are running in opposite direction. You will find that this car is actually overtaking you or crossing you extremely fast. Correct? Why this happens? Because you are assuming you are at rest and your speed get added up with the speed. Correct? This is the concept of relative motion. So what we do, in order to explain relative velocity of one with respect to other, say for example, A and B are the two persons. Okay? Moving in this direction. Velocity of A is VA and velocity of this is VB. So when I am saying the velocity of A with respect to B, that means I am assuming B is at rest. Correct? And assuming with respect to B means B is at rest. That means we are looking from the viewpoint of B. Means when B is watching A, B is assuming I am at rest, and what is the speed of with which BA is approaching? Okay, so what we say in this case, velocity of A relative to B or with respect to B is equal to velocity of A with respect to ground minus velocity of B with respect to ground. This is the specific definition of relative velocity of one with respect to other. Similarly, acceleration of A with respect to B, that is, this is called relative acceleration, that is acceleration of A with respect to ground minus acceleration of B with respect to ground. So this is the general definition of relative motion, correct? So let me do some problem related to this so I can able to build your concept more stronger, correct? So let me handle a question first. Look at this. Suppose a person is running on a road with a speed of 2 km/h and direction is mentioned. This person A. Another person B is running in the same direction with a speed of, say for example, 5 km/h. Okay. Now what will happen? If you observe, look at the motion of A from the viewpoint of B or motion of B with respect to A, what will observe? So let's find out this. So write down first velocity of A with respect to ground. It is moving towards right. So it is the direction of positive x-axis. So I would like to write this as 2i cap km/h. Now velocity of B with respect to ground is what? 5i cap km/h. Now what is the velocity of A relative to B? Means if we keep B standstill, correct? So if you look at the from viewpoint of B, that means I am observing the motion of A from the viewpoint of B. That means B is assuming B is at rest and with what speed A is approaching, correct? So look at this. What we do, velocity of A with respect to B is velocity of A with respect to ground minus velocity of B with respect to ground. Now, what is the velocity of A with respect to ground? Look, it is 2i cap. And what is the velocity of B with respect to ground? It is 5i cap. So, what will happen? It is minus 3i cap km/h. So, what B will observe? B will observe that A is moving away from B with a speed of 3 km/h. This is the meaning of the negative sign. Okay. That means since look, A is moving for B is moving faster than A with respect to ground. So slowly A move more far from A with time. So B will observe that A is moving away from him with a speed of 3 km/h, or we can say B will observe that A is moving at a speed of 3 km/h in the opposite direction. Now, what will happen if you want to look at the point of view from A? So, velocity of B with respect to A is equal to velocity of B with respect to ground minus velocity of A with respect to ground. What is the velocity of B with respect to ground? Velocity of B with respect to ground is 5 I cap. And what is the velocity of A with respect to ground? Velocity of A with respect to ground is 2i cap. That means 5i velocity of B with respect to A, that is 3i cap. That means velocity of B with respect to A means what? A, if I keep A constant, so 3i cap means A will find that V is moving away from him with a speed of 3 km/h. Correct? That means A will find B is moving away from him along this direction with a speed of 3 km/h, but B will find A is moving away from him in this direction with a speed of 3 km/h. This is the interesting portion of relative motion, correct? Okay, let's handle more problem related to this. Suppose there is a trolley, okay? and this is person A, and velocity of the trolley with respect to ground is supposed to be given, trolley with respect to the ground is supposed to be given at 20 kilometers per hour, and velocity of A with respect to trolley. Okay, suppose A is the long trolley, A is also moving with a speed of, say for example, 5 kilometers per hour. So velocity of A with respect to trolley is 5 kilometers per hour. Correct? Now let's take this example. B is standing on another trolley. Okay? And B is moving with a speed of 3 kilometers per hour with respect to the trolley. Correct? So write it, velocity of B with respect to the trolley is 3 kilometers per hour. And this trolley is moving with a speed of, say for example, 50 kilometers per hour with respect to ground. So velocity of, this is another trolley. So let's write down, this is T prime. Okay, this is T prime, this is T. Okay, so velocity of this trolley with respect to ground is suppose 50 kilometers per hour. Now you need to find out what is the velocity of A with respect to B. This is the question. So how to tackle this? We know that velocity of A with respect to B is equal to velocity of A with respect to ground minus velocity of B with respect to ground. Now our task is to find out this first, correct? Now look, velocity of trolley with respect to ground is equal to velocity of this, sorry, just a moment. Velocity of the trolley, velocity of A with respect to the trolley, velocity of A with respect to the trolley, velocity of A with respect to the trolley is, say for example, what is that? Velocity of A with respect to ground minus velocity of trolley with respect to ground. Correct? Now what is the velocity of A with respect to ground? We don't know. Now velocity of A with respect to trolley is what? We have to use I cap for this and J cap for this, correct? Now trolley is moving towards positive x-axis. Okay, so what is the velocity of the trolley with respect to ground? This is velocity of the trolley with respect to ground. What is that? 20 I cap. And what is the velocity of A with respect to trolley? It is also moving towards positive x-axis. So write it 5 I cap. So velocity of A with respect to ground would be what? Velocity of A with respect to ground is equal to 5 I cap plus 20 I cap, that is 25 I cap kilometer per hour. Correct? Now do the same thing for this. So velocity of B with respect to trolley is equal to velocity of B with respect to ground minus velocity of trolley with respect to ground. Now what is the velocity of B with respect to trolley? Look at this, this is 3 kilometers per hour. Okay, so writing it 3 I cap because it is arrows are given in the direction of positive x-axis. What is the velocity of B with respect to ground? Seriously, we don't know that. Correct? Now what is the velocity of trolley with respect to ground? It is given 50 kilometers per hour. An arrow is given towards positive x-axis. So write it 50 I cap. If you do that, velocity of B with respect to ground would be 53 I cap kilometer per hour. Okay. Now, if it is so, now we can solve this part. What is that? Velocity of A with respect to B, velocity of A with respect to B is equal to what? Velocity of A with respect to ground minus velocity of B with respect to ground. Now, velocity of A with respect to ground is what? Look at this. Velocity of A with respect to ground means this 25 I cap minus what is the velocity of B with respect to ground? It is 53 I cap. So what is that? 25 I cap minus 53 I cap. What is that? 8, 28 minus I cap. That means we will observe that, correct? A is moving away from B with a speed of 28 km/h. This is the technique of solving this kind of sums, correct? So let me show you another problem related to this. So now let's take a situation like this. Say for example, this is another trolley. Okay, and this trolley is running in the backward direction with a speed of, say for example, 50 km/h. And this person this is a long trolley, is moving forward with a speed of 2 km/h, and this is with respect to the trolley. With respect to trolley. Now, there is another trolley which is moving in this direction with a speed of, say, for example, 20 km/h, and another person, B, is running on this long trolley with a speed of, say, for example, 3 km/h with respect to trolley. This is T2, this is T1. Now the question is, what is the velocity of A with respect to? Correct? So very simple. What to do? In order to find out velocity of A with respect to B, what I have to do first? I have to write it like this: velocity of A with respect to ground minus velocity of B with respect to ground. Correct? So what I'm doing, first I'm writing down the given informations, correct? This is the velocity of the trolley 1 with respect to the ground. So velocity of the T1 with respect to ground is, it is moving backwards, so it is minus 15 I cap km/h. Correct? Now this is what, this is the velocity of the person with respect to the trolley 1. So let me write this A. So velocity of A with respect to trolley 1, it is in which direction? Positive x-axis. So I would like to write this as 2 I cap km/h. Correct? Now write down the information given over here. Velocity of the trolley T2 with respect to ground is 20 I cap km/h. And what is the velocity of this person? I'm naming this person as B. Okay. So velocity of this person B with respect to trolley T2 is minus 3 I cap km/h. Okay. Now look at this. From this we can able to find out velocity of the trolley with respect to ground is what? Look, let me apply the simple rule. Okay. What is that? The rule is this. I told you this earlier. Velocity of the trolley 1 with respect to ground is equal to what? Oh, sorry, just a moment. Let me write down this first. Velocity of A with respect to trolley 1 is equal to what? Velocity of A with respect to trolley 1 is equal to velocity of A with respect to ground minus velocity of T1 with respect to ground. What is velocity of A with respect to ground? We don't know that. But what is the velocity of A with respect to trolley 1? That is 2 I cap. Velocity of A with respect to ground unknown to me. velocity of the T1 with respect to ground is minus 15 I cap. So what would be that? 2 I cap. If I solve it, 2 I cap is equal to velocity of A with respect to ground plus 15 I cap. That is velocity of A with respect to ground. This goes that side, minus 13 I cap kilometer per hour. Is it clear? Now, what is this? Now let me come to this part. Velocity of the B, velocity of the person B with respect to trolley T2 is velocity of B with respect to ground minus velocity of the trolley T2 with respect to ground. Correct? So what is the velocity of B with respect to trolley T2? It is given minus 3 I cap. Correct? And what is the velocity of B with respect to ground? Seriously, we don't know. And what is the velocity of T2 with respect to ground? Is 20 I cap. Now, if I take it in that side, the velocity of B with respect to ground will be 17 I cap kilometer per hour. Now, what we have to find out? Velocity of A with respect to B, which is nothing but velocity of A with respect to ground minus velocity of B with respect to ground. Correct. Now, velocity of A with respect to ground is what? Look, it is minus 13 I cap. Put that value. Minus, this is 17 I cap. 17 I cap. So if I add up this will be 30 I cap kilometer per hour. So velocity of A with respect to B, that means with respect to B, B will observe that A is moving backward with a speed of 30 kilometer per hour. Is it clear? Is it clear? So this is the technique of solving the problem related to relative velocity in one dimension. Now, think for a moment an example. Another example, okay? Suppose a man is moving along this direction with a speed of 2 kilometers per hour. Correct? And another man, when the distance between them is, say, for example, 50 meter, 100 meter. Okay, don't write it 100 meter. Let's make it 1 kilometer. Clear? This person starts moving with a constant acceleration of 0.5 meter per second square. Correct? After what time? After what time the person A can able to catch the person B? Okay. So let's write it this B. So let's make B as the observer. Okay. So initial velocity of A with respect to B is what? A with respect to ground and velocity of B with respect to ground. What is A with respect to ground? Is 2 kilometer means 2 I cap, and this is 0. So 2 I cap kilometer per hour. Now, what is the acceleration of A related to B? That is acceleration of A with respect to ground minus acceleration of B with respect to ground. Acceleration of A is 0. But what is the acceleration of B? It is 0.5 I cap. Okay? Clear? It is not in meter per second square, it is kilometer per hour square. Kilometer per hour square. So what will be the value? 0.5 I cap kilometer per hour square. Now it is the observation of B. So B is standing still. He is finding A starts moving initially with the speed of this velocity, and the acceleration of A is with respect to B is 0.5, but it is minus. Okay. Now let's apply the formula. A is equal to U relative UAB into T plus half AB into T square. What is S? Because he is thinking he is at rest. So separation is 1 kilometer. So they try to 1 kilometer. What is UAB? What is UAB? It is 2T plus half. What is this? This is 0.5, but minus T square. Okay. So now watch it carefully. What is that? 2T. If I simplify the result, the thing will come like this: 2 equal to 2T minus 0.5 T square. So let's write it in this way. Make 0.5 as 2. Multiply 2 on both sides. It is 4T minus T square. T square minus 4T plus 4 equal to 0. So what is that? T minus 2 whole square equal to 0. That means T equal to 2 seconds. Okay. So after 2 seconds, take the calculation. T square minus 40 plus 1. After 2 seconds, A can able to catch B. Correct? So this is another type of problem. Now let me show you problem related to vertical motion. Correct? Now think about a question. Suppose there is a tall building. Okay, there is a tall building and a person standing on the ground. A person standing on the ground and throwing a ball upward. Throwing a ball upward with a speed of, say, for example, 50 kilometers per hour. Okay. And another person is standing here. He is throwing a ball downward with a speed of 20 kilometers per hour. And the height of this building is supposed to be 40 meters. Height of this building is supposed to be 40 meters. Okay. So question number 1 is, find the time after which the ball will collide. With each other. And number 2 is the distance or height of the point of collision. Height of the point of collision from the ground. Okay. So what we do here? Let me tackle the problem in this way. First of all, let's make any one person as the observer. Correct? So name it the person as B and name this person as E. Okay. Now look, velocity of A with respect to B. What is that? Velocity of A with respect to ground minus velocity of B with respect to ground What is the velocity of A with respect to ground? Look, velocity of A with respect to ground means A is throwing this ball in upward direction. So it is 50. Velocity of A with respect to B. Observe what is B, correct? And velocity of A with respect to ground, A is throwing the ball in upward direction. So it is 50 j cap. What is the velocity of B with respect to ground? B is throwing this ball in downward direction. So it is minus 20 j cap. So what is that? 70 j cap. That means we will observe that A is throwing this ball towards him with a speed of 70. Means if you observe, not B, observe the viewpoint of the ball. Okay, B. And this is the viewpoint of the ball A. Means if you observe from this observation point, the motion of ball A, you will find this. Okay, clear? That means from the viewpoint of the ball B, A is moving towards it with a speed of 70 j km per hour. Now, okay, let's do one thing. Don't make it kilometer per hour, make it meter per second. Okay, okay, make it meter per second, and it is meter per second, meter per second. Okay, so it is also meter per second. Now, when we throw anything upward, downward, it is under the control of gravity. So in this case, acceleration will play an important role. So we need to find out acceleration of A with respect to B, that is acceleration of A with respect to ground, and acceleration of B with respect to ground. Now, what we know, in case of under gravity concept, clear, or motion under gravity, we know G always acts in downward direction. So it is minus G, J cap, and it is minus G, J cap. So it will be what? 0. So this is the interesting part of the relative motion in vertical motion. That means we don't have to calculate any relative acceleration, because relative acceleration always comes to be 0. Now, what is the intermediate separation? 40 meters. So the time taken is, since it is non-accelerated motion, it is uniform velocity motion, we can simply apply S equal to Vt. So time is equal to distance by speed. Distance is what? 40 and divided by 70. So time taken would be 4 by 7 seconds. So simple. Now, the second part of the question is the height of the point of collision from the ground. So in this case, what you have to do, correct, look at this. Suppose this is the height at which collision occurs. Clear? I don't know the value of the height. Let me write this as h. So applying the formula, A is equal to ut plus half at square. So u is what? 50 meter per second. Okay, time is what? It is 4 by 7. Okay, and plus half. What is A? It is minus 10 because G, and T is what? 4 by 7 whole square. You can do this calculation very easily. It is 200 by 7, and it is, this get cancelled, 5 minus 5, 4 4s are 16, 16 5s are 80 by 7 square means 49. Correct. So 7 square is 49. So this 1400 minus 800 by 49, that is 600 by 49 meter from the ground. It is around 12, 14 meter, 14 point something meter, correct? So this is the technique of solving the sums related to relative motion. Now, let me show you another interesting problem.